So the representations that we're working with don't just exist on paper. They describe things that actually happen in the lab and that we can observe. And so I want to talk about some rules of thumb for what we can look for when we see certain kinds of pieces in a chemical reaction. So one thing to look for, when you have a pure metal, that's going to tend to be shiny. So when you have something like copper, zinc, aluminum, and silver, these are all metals that we use quite a bit in chemistry. These are all examples of pure metals. If you have one of these showing up just on its own in a reaction equation, you're going to expect to, in the lab, observe something a little bit shiny. It's not always exactly true. Sometimes when the metals are in certain forms, they aren't as shiny. It's more likely when they are a reactant that you're going to see that shininess, but it's something you can look for in general. Now, when you have a metal oxide, that's when you have any of those metals above bonded with one or more oxygens. You're going to have a metal oxide. These are very consistently kind of a dull color. So if you think of rusted iron where you've got that dull reddish flaky color, that's a good example of a metal oxide. Now, another good rule of thumb is when you have a compound that's just two of the same element, so for example, if I have O2 or if I have H2, these are both really common ones. These are going to tend to form gases. And so if you see bubbles or you hear fizzing, these are signs that there are gases escaping your reaction, which could fit with one of these being produced. Some other gases we're going to see a lot are carbon monoxide and carbon dioxide. If either of these are formed, that also tends to be a gas. And then another good rule of thumb is just to look for color changes. A lot of chemicals have a particular color that they tend to appear. Sorry about my sloppy C there. So for example, a lot of copper solutions, so liquids that include copper, tend to have this real pretty blue color. If you start with a copper solution and you see that nice blue, and then over the course of the reaction that disappears, that can be a sign that that copper solution changed into something different. So now that I've told you a little bit about some of the rules of thumb for how to connect observations to chemical reactions, I want to go ahead and do an example of a chemical reaction. Now, I'm going to do one using some materials that you might have at home. And so if you have these supplies and the other people you're living with are okay with it, feel free to try this. This is a pretty safe reaction to do. I'm going to use baking soda and some white vinegar. Now the reaction looks like this. So this is the formula for baking soda. This is the chemical formula for vinegar. And so if I were able to actually break down that baking soda and that vinegar, I would find in the baking soda, each molecule of baking soda would have 1 sodium, 1 hydrogen, 1 carbon, and 3 oxygens. Now they're going to react to form these pieces. I'm not going to worry too much about all the names, But there's a couple things in particular I want to latch onto to think about what we're going to see. So first up, one of the products here is CO2. Now CO2 is one of those that tends to form a gas. So I'm expecting to see some signs of a gas being formed. H2O, that's just the chemical formula for water. And so I'm expecting to see something that looks like water at the end, which will be just a nice clear liquid. So I'm going to do this reaction in a little jar. So I'm going to put a spoonful of baking soda in. Now this can get messy, so I'm putting a lid on here. And I'm going to take my vinegar and I'm going to pour just a little bit in. And you'll notice how much it's foaming and fizzing. I can see all those bubbles. So those are signs of a gas being formed. I can even hear it. That little bit of hissing. So I've got bubbles and I've got hissing that tell me there's a gas being formed. Going back to my equation for this reaction, that fits with this CO2, since CO2 tends to form a gas. And I'm going to pour some more vinegar in here. Oh, and I'm putting the lid on. Just, it bubbled up a little more than I wanted it to. Trying not to make a mess. And I can hear that fizzing pretty well. Now this liquid still looks kind of whitish, but some of that is, there's some leftover baking soda floating around in here. But the liquid, aside from that, seems like it's probably fairly clear, which matches with the water. And in fact, if I let this sit for a little while, I probably would see that baking soda settle out and I'd get nice clear water.